Thank you for the introduction. So I'm Irene from Cryptonet, and I'm going to go deep dive in a project that was one of the focus for our team during last year, and it will continue working on this next year. So the question that was the motivation for this project is how we can guarantee retrieval from decentralized storage network. And if you remember one talk, we want a solution that is web scale and can allow to onboard unbounded amount of data. Okay, so something that really scale well and it's efficient. Let me start with a bit of context. I know that you all know probably here, but it's nice to recall this. We have a network of storage providers that work in this simple way. Clients can send a file to many providers, they store, and they have a primitive that, let's call it in a generic way, a proof of storage, that can be used from the provider to prove publicly to the client, actually publicly to everyone, that the storage service was provided. And this proof now, it's also the key to get a payment. It could be block reward, could be other payment, but it's the key that enable for an easy way to incentivize storage, right? This is very high level how Filecoin works, and this proof, actually Filecoin is the window post, right? We all know this. When you go to the retrieval phase of storing data, there is not an equivalent, right? Retrieval right now is just assume that some provider is honest and will serve the data. There is not really incentive. We have seen this, right? We are here because of this problem. So we call this problem the data retrievability problem. And why it's complicated from let's say from a research point of view, because you don't have the equivalent of proof of storage, so there is not a proof of delivery. At least we don't know how to do in a simple way a proof of delivery, because if you have the proof of delivery, then you can use that in the similar way as you use the proof of storage and problem solver. But there is no proof of delivery. It's actually from the research point of view, we can prove that it's impossible to design a proof of delivery, because if you have proof of delivery, we have a fair exchange, and we know that fair exchange without trust assumptions is impossible. So we need to add we need to ask help, we need to add some trust assumption. That's the way we call this help from a third party in the research world. Some practical trust assumptions, so who can help us to get to solve the data retrievability problem, is of course you can have a blockchain and that just publish the data on chain. If you think for a second, this is the data viability for layer 2 for rollups, what is really doing. So if you really want some data to be available, just publish on, I don't know, Ethereum with some sharding or Celestia, right? So that are there for sure. But this is not web scale, so this is not something we can use for the kind of storage, data storage that we are focusing here with the Filecoin. Another solution that is around is proof of retrievability. Proof of retrievability is a primitives that you can think about it as I check your storage frequently, and this proof, they don't just show me that the storage is there, they slowly leak the data. So it gives you retrievability, because leaking the data gives you retrievability. But this is really, right now it's still slow. Maybe research will improve this, but right now it's not something that we can use at scale. So the third option here is to talk about what we call the retrievability oracle. So this is somehow a third party. Behind the client and the provider, we have this oracle that we can use as a semi-trusted party that we can ask help in case that the retrieval service is not provided. I'll explain more. This is actually the solution we try to implement, so I'll explain more about what this means. How we implemented the retrievability oracle idea is this, we did what we call the retrieval pinning protocol. And the idea is that we have a separate network, small now for one, we have 5 nodes only, but in principle, you can scale this. 5 nodes just because we have a test phase of this, but in future we can scale, hopefully. And these are our referees, our oracle. We don't need to trust all of the node in the network, of course. For now, for example, we need to trust the majority. Future work, we may even trust, we even maybe need to trust that. Then, so we have the client, the providers, and the referee network. And then what they interact via smart contract. So the interaction between these 3 parties is going to happen thanks to a smart contract. The client use the smart contract to create a deal proposal. So there is a function that creates this deal proposal. The deal proposal is about the retrievability. So I want to store this data and with retrievability service for this time, for a period of time with other information. Providers can accept thanks to the accept deal function, and then the client can ask the referee oracle help using create appeal. Okay, so this is where the referees will get activated. Otherwise, it's only between the provider and clients. The last function that you see is the redeem deal, because of course, if everything goes well, the provider is going to be paid by the for his service. So let's go in this bit more in detail with this, what is the deal between the client and the provider. So the client and the provider, they need to agree on which files or folder of files is going to be stored with the retrieval service. This is going to be identified by this data ID. They agree on the duration, so I'm going to provide this for 1 month, 1 year. And then there is these 2 values, tokens, the payment and the collateral, okay? The payment is the usual payment for the service that is locked down in the contract. The second value, the collateral, is this, is kind of the new one, that is the deposit, somehow the collateral that the provider has to do. It's locked down in the contract, and it will be the assurance, the retrievability will provide the retrievability assurance. Go ahead. Anna.
A separate deal from the storage deal, one, and then the other thing is that, doesn't the storage deal already have a collateral associated with it?
Storage deals? No. So this is separate now because this is, you know, a smart contract on an AVM compatible. It's not actors on Filecoin yet. Once we go,
could be this.
Could be, yeah, could be all together. Why not? Actually, yeah. So how it works? If there is a problem at some point, so if the client is not happy with the retrieval service from the provider, what they do, they call the create appeal function and they activate the referees. They activate the referees to try to, let's say, check the provider why is not providing the service. Basically, the providers, we have like a protocol written down how the referees really interact with the provider. There are several rounds of interaction where they basically ask the provider to send them the file to recover. So the referees, in few words, they try to recover the file from the provider. If this happens, no problem. There was like maybe some misunderstanding between client and provider, but the referees solved the problem. The files go back to the client who is happy, retrieval was successful, provider gets this payment. If the referees, after several attempts, they agree that this provider is not providing retrieval, they have the ability to slash. We say slash the provider, what means they take the collateral that was in the smart contract, locked in the smart contract vault, and basically this is born away, okay? So the provider loses this. And the payment, of course, the provider doesn't get the payment, and this is, the client got it back, this. So from the security point of view, so I didn't go into detail of the protocol. We have a light paper, go on the retrieval.org website if you want to read more about it. But the way we design it assures that a provider that does not send the file during the appeal will be slashed, even if he can like how you say, corrupt and collude with some of the referees. So we have a strong assurance that the slashing will happen. On the other side, we want to protect provider to be slashed for nothing or for just clients trying to abuse of the protocol. So we have actually, for this reason, we can prove that even if the client acts malicious and try to collude with referees, the honest provider that answered during the appeal phase will not get slashed. Go ahead.
You're saying 2, but is that like 2 out of, is it proportional or is it absolute?
Yeah, no, it's proportional, thank you. It's like, for now, it's, as I said at the beginning, we need to, you can corrupt at most the minority. So we need half of the referee to be honest. This is a parameter that maybe in future can be changed. Yeah, I'm using the specific number of the implementation that we have now, sorry. On top of this, so this is, the security that the protocol gives you, and then, of course, we have the cryptoeconomic incentives that work here. So on one side, we have the assurance for the client. This is represented by the collateral, okay? So we have a model, we did analysis and run simulation, and we can say that if the collateral is in the range between payment and 1,000 times payment, this makes sure that a provider that accepts the deal will provide the retrieval service, because otherwise it's going to lose too much money, okay? So it doesn't make sense to accept the deal and then I'll see if I give the service or not. That's not make service. So it makes accepting a deal something really committing for the provider on the retrieval service. On the other side, we have the appeal fee. Appeal fee is how much it costs for the client to ask the help of the referees. We can't make it free because otherwise client can just abuse the protocol, could just try to, DOS the protocol or make a provider, or DOS a single provider to get it slashed at some point. So we have to make it a bit costly to ask for these appeals, and that's the suggested parameter. Still on this, still to be sure that the protocol don't get abused, we have also a max number of appeals. Simulation showed that 5 was a good number here.
Is that over a time period?
5 number of appeals for the period that is in the retrieval deal. So for all the period that the deal is active, you have this. Go, Maria.
I'm curious, so this is just for like one retrieval request, right? What if it's
So not really one retrieval request. We have a retrievability deal for 1 month. In that month, you can ask how much retrievals you want for that file. If at some point you stop answering the retrieval, I go and appeal and say, hey, this guy is not giving my file back anymore. It's not like, it's a retrievability deal that says, I want to be sure that I can ask back this file in the next 6 months. How many times? It's not, right now it's not a protocol parameter. Maybe you can make it because otherwise it's unfair for the provider, but right now it's not.
So you're not kind of getting into that territory yet, the company?
Yeah, we're not.
So when there's an appeal, does the person doing serving the retrievals, will they get some sort of to pay anything even if they are successful in the appeal?
Yes. So if the provider is successful in the appeal, they don't lose money, so the collateral is not lashed, and they get the payment. So everything works.
They are not incentivized to actually give, right?
Yeah, that was one of the design. When we were designing this, should we give back the payment even if they give the file through the referees or not? Because it's an incentive to not answer to the client, but only answer the referees. But on the other side, if they are doing the retrieval, even during the appeal, they are doing the retrieval service. So we thought the payment was, they should get paid for the retrieval service. They're just doing it later. So something that we can do in the future is maybe we give them less payment. I don't know. This is good point. Good point. So far is.
If you think that the client would be like the malicious party, the client would just avoid asking the file directly to the storage provider and always go through the referee if he wants to penalize the storage provider that is honest. So that was like the balance that we found in the middle.
Yeah.
I want to hold off on the questions. We have a whole day of workshop ahead. I will let Irene get through.
Yeah, we will love to.
Yeah, we will discuss all day.
No, but we will love. This is. I mean, it's designed like this, but feedbacks and new design are really welcome here. Stop with the. I think this is all the technical info I'll give for today. If you want to know more, go to the website or just ask us. We are here. In the next few slides, I want to show you what we have, what you can test directly. So if you want to test because we have actually 2 deployments of this live. If you want to test as a client, so as someone that store and then ask to retrieve some files, we have an app that you can use. The app, it's simple, just allow you to drop a file, choose a provider with which you want to do the deal. So right now we have only 2 providers. One is in the room, one is web3.storage, no, nft.storage. You can choose the parameters of the retrievability deal that I explained before, so the duration, the payment, collateral, and then you sign everything with, of course, this app asks you to connect with some wallet like MetaMask, and then you sign with MetaMask or the wallet. And in the app, you can also, once that you have made deals, you can also see the list of deals that you have and manage deals, meaning you can request appeal directly from the app, so you don't need to really interact with the smart contract from command line. And you can see if there is an appeal, you can see how the appeal is going. As I said, the appeal is long, like there are different long, so it lasts for 1 hour, something like that. So you can see how it is going, if it's successful or not, and go ahead and test, and feedback are welcome. On the other side, on the provider side, we have, first of all, we really, one of the next steps for us is onboarding more providers. This is key to test this protocol, client and provider. So if you are interested to join us as a provider, please just there is a QR code that you can scan now, and so you send us your contact, and we will be in touch with you. There is the GitHub repo with the README, so it's also easy to set your own provider. What I want to say about providers, that we have a provider information strategy that is decided by the provider itself. So a provider that join our protocol can set up the maximum size of the files that they accept, the max deal duration, max payment, and collateral. Of course, he has the possibility to set up his own parameters. There are the default values, but depending on the storage capacity and other maybe constraint, it can set up different values. And then the provider works mainly from this interface where that it's explained in the README in the GitHub repo, where you can see how many deals you are accepting, the deposit that you need to lock down, and all these other parameters from the provider's point of view. What else? So basically, what Cryptonet did for this particular project in 2022 was going from something that was an idea, an MVP in May, this year in May, to something that is a test product. As I said, like we are now live on Ethereum early testnet, and we are also live on Polygon mainnet. And you can really use this protocol for storing and retrieve data. Right now, the release that we made are in the safe, what we call the safe mode. So the payment and therefore the collateral and everything is set by default to 0. Why? Because we didn't have yet the opportunity to run a proper smart contract audit. Of course, our engineer checked the smart contract code, but we didn't run an external audit. So the next step, practical short-term next step is a smart contract audit to enable payments and really test on the ground, test in real life the crypto economic model that we have. As I said already before, we want to onboard more providers and clients. Talk to us if you are interested or have suggestions in this. We want to have another release, a third release on Arbitrum. This is to get full compatibility with EVM, with the Ethereum ecosystem. So access our protocol, access storage, actually in Filecoin and IPF directly from Ethereum. And then also we are working to a Filecoin release, let's call it that way at some point. So we want to have the Filecoin AVM compatibility ready soon. More open questions that we will keep brainstorming is, as I said before, we have now this small network of 5 referees. In the future, maybe we want more referees with a different threshold of how much you have to trust, and why not multi-network referees, so not just one network, many networks that are really providing this service. We already brainstormed, and we already have thought about how we can enhance the incentive mechanism with the reputation. I mean, also Marina showed us that reputation can really be a strong incentive, even if it's not about really tokens and crypto economic. So maybe we want to, give so looking at how much a provider has been slashed or this kind of data from our protocol, you can construct a reputation system that is another incentive for retrieval. And there are other improvement for efficiency, and not just for efficiency, but depending on the use case that we will want to focus on next year, we may want to have improvements like, for example, ability to batch deal proposal, and also deal acceptance. So we may need to redesign part of the protocol for the next release. And that's all. Questions? Or maybe in the brainstorming section, I don't know if I'm allowed to. Okay. Yes?
Did you look at participation incentives? Because with collateral so high, how do we incentivize participation even in retrievals? Other ways to tie it to the original deals? Or do we just expect that the income generated is going to be high enough to incentivize it?
I mean, yes. I think it's the second point. The model suggests that it's true that the collateral can be very high. I mean, it doesn't have to be so high. It's in a range, right? But it's always proportional to the payment, okay? So this means that you can really gain a lot if you provide this retrieval service through this particular protocol and deal. Okay, so it's true that you have to maybe lock down because of the collateral a big amount of tokens, but it's always proportional to what you really gain. And if you are doing a good job, there is no concern of being slashed. So it should work as the collateral should not be a disincentive to participate, at least from the model and mathematical point of view. Then we can talk about psychology, because of course we really need to understand how providers feel about that anyway. Yeah.
I would say if you go to the lower range, so if the collateral is the same as the payment, then it's like you're doubling your money in terms of investment, right? Like you are paying X and you are receiving 2X.
It's a risk that we're turning out to 1,000.
Yeah.
There is a risk. It's a perceived risk, right? Yeah.
Can you have multiple challenges happening at the same time? No? So that
Challenges, you mean appeals?
Yeah.
Yeah, no.
So that means I can I can make sure that they're providing 1 copy per hour at fastest? Mm-hmm. Are there ways to, so like, does it make sense to be able to pay for, like, how do I say I want you to be serving 1,000 an hour or 5?
Yeah, we don't really have metrics. This is actually should have this maybe in the open discussion. There is, as I said before, I think to Marina, no, it's a related problem. There is no metric involved. We could do a deal that you guaranteed retrieval with these metrics. We are not doing that. It's not easy, but it's interesting for sure, yes.
What use cases do you think will fit well this protocol?
That's the hardest question of today. Use cases. I don't know. I think right now this is not the can scale. If I think about one slice, we can't really scale to video now with this kind of protocol yet. It's most the use cases. So I think we were kind of in our head, what is stored right now with, I don't know, Web3 bounty, NFT storage, maybe NFTs, I don't know. Maybe the data on File Plus program can, I know that it's a bit weird that because they have the extra copy, so we have to understand if it's rare or not, but right now is small data that we can support. We definitely want to understand how we can scale. I don't know if other people from the team have other insight here or, yeah. This is actually one of the things that we have an hack day later on to understand what are the best, open to suggestion here. Thank you.